All right, here we go. We got two planes. This is problem 5. And so what I'm just going to do is read off the normal vectors from those planes. So plane 1 has a normal vector of sine alpha, cosine alpha, that's an alpha, and 1. So this is normal vector number 1. Normal vector number 2 is cosine alpha, sine alpha, and negative 1. And we are asked to show that these two planes are not perpendicular. If the planes are perpendicular, then their normal vectors are also perpendicular. And if things are perpendicular, their dot product makes 0. So let's see if this makes 0. So n1 dot n2 is equal to, okay, this will be a lot of fun. Let's see. Sine alpha times cosine alpha plus cosine alpha times sine alpha minus 1. And that is 2 times sine alpha cosine alpha minus 1. And we are asked to show that these are not perpendicular. Yeah, that feels weird to me. That feels very weird to me. Let's see here. How could I make that equal 0? Well, let's try to make it equal 0. If I wanted to make that equal 0, I would get that sine alpha times cosine alpha is equal to 1/2. And I think, unless I'm crazy, that happens when alpha is pi over 4. Because if alpha is pi over 4, then we have sine of pi over 4 is root 2 over 2. Cosine of pi over 4 is root 2 over 2. And if you multiply those, you get 1/2. And that would make it equal 0. All right, that's interesting. So I am finding that it is possible that I made a mistake or that the textbook made a mistake. Let's see here. What was their intent? Their intent was on problem 5. Then their normal vectors are always perpendicular. So we check these planes are not perpendicular. Okay, that's cute. So it seems they neglected that sine alpha times cosine alpha can equal 1/2, which is a sad fact. Okay, so I guess the way to answer this question is that these planes are not perpendicular when alpha is not an angle that makes sine times cosine equal positive 1/2. So that I'm going to answer the question better than they wrote it. So alpha could equal pi over 4, or alpha could equal 5 pi over 4, because at that point, sine and cosine would both equal negative root 2 over 2, and you'd also get it equaling 1/2. And you could also add any multiple of pi to it. And so the best way to answer this is just that uh, the planes are perpendicular when alpha equals pi over 4 plus pi times n, and n is an element of the integer. So any integer multiple of pi will result in perpendicular planes despite what the textbook asks you to show. That's a lot of fun. Okay, thanks everybody. Let me know what else I can do to help.